Hello, today we will be discussing the topic of rational root theorems by Sarah Gomez. We will use rational root theorem to find potential zeros, use long division for that zero, and find the zeros of a reduced polynomial. The problem that we will be doing today is 2x cubed minus 5x squared minus x plus 6. The first step in the rational root theorem is to divide the factors of the last term over the factors of the first term. You have to keep in mind both negative and positive numbers. The factors of 6 include positive and negative 1, 2, 3, and 6 over the factors of 2, which include positive or negative 1 and 2. Second step is to divide by each of the factors both on top and bottom, which give us the number 1, negative 1, 2, negative 2, 3, negative 3, 6, and negative 6. And then divide by 2, which are 1/2 and negative 1/2, then 3 over 2 and negative 3 over 2. The third step of this equation is to take one of the number that it gave us as a result of dividing and turn it into an equation that equals to 0. Since the signs change when we do this, the equation to the number negative 1, the number that we are using now, gets changed to the equation x plus 1 before dividing. Then inside we put the original equation. We then divide using long division. We say, what number times x gives me 2x cubed, which is 2x squared, and then we have to align it in the same term that the variable is similar to. Then we times 2x squared times the equation x plus 1 and put its product in the correct variable as well. We subtract always and distribute the minus sign. And then, what the remainder gives us, we lower it to the term and continue doing it until the equation is complete. At the end of the process, we see that the remainder does not give us 0. Therefore, the number negative 1 does not work as a zero of this equation. We will move on to the next number, and we will do the number 2. We will undergo the same process. Remember that the equation has to be x minus 2 because we changed the signs. We see the same process, and at the end of the equation, there is no remainder, therefore proving that the number 2 is a zero of an equation. The next step is to take the equation that was made after dividing and the equation that already gives us 0, which was x minus 2. Now that the equation has somewhat been simplified, we factor out the second equation like we would do normally. We multiply the first and last term to make up the product, and the middle number to make up the sum. We then look for the factors of 6, that in this case are 1 and 6, 2 and 3. Then the numbers of 2 and negative 3 gives us the sum that we are looking for. We then plug it in the quadratic equation where the x was before. We then take out the common factors of these two terms near each other and then create two equations. These equations will be the one that gives us 0. And we have found the zeros of a function by using the rational root theorem.